So let's look at question number 13 from the Revised Higher Physics 2014 paper. And what we've got here is a question about refraction, and it says a diagram shows a path of a ray of red light passing from air into substance X. We're not told what substance X is. The critical angle of the substance in X is, and there are a range of options here, 32, 41, 45, 52 and 90. So what we need to determine is the angle we need to, the formula we need to use to get the critical angle. And that, according to the data booklet, is that the sine of theta c is equal to 1 over n, the refractive index. We're not told the refractive index of this substance anywhere in the question. So what we must first of all do is determine what that refractive index is. And so the best way to do that is to use the other formula, Snell's law, sine theta 1 over sine theta 2, which I commonly teach my class as sine of the angle in air over sine, hold on a moment, just tidy that up, of the angle in the glass. And so this is the angle in the air, theta A, and this is the angle in, it's not glass, substance X. I'll just call it theta G, since I've labeled it theta G over here. So we plug those numbers in and we'll get a value for n. So n is the sine of 46 over the sine of 28. And that comes to 1.53. So that's our refractive index. So now we can use this formula up here to determine the critical angle. So therefore, sine of the critical angle is equal to 1 over 1.53. And so the inverse sine of that will give us the critical angle. And so the inverse sine is 40.8 degrees. And that means to 2 sig fig, as everything is to 2 sig fig, this is 41, and so the answer must be B.